Hello students, in this lecture also I'll be continuing with piping and instrumentation diagram. In this lecture I'll be talking about the pipes, tubes and hoses and their symbols that are used in P&I diagram. So the process lines are the lines. This pipes, tubes and hoses, they are called the process lines. So these are the lines where the process media actually flow through, and they are represented by different types of lines. So on a complete PNID, each line will be labeled with a line number, and this label will either run parallel with the line or with a call out line pointing to the line being defined if it does not fit on the line itself. So the label will include information about the size, class, insulation and more. So talking about the various pipe symbols, so there are two methods. So you can see these are the various pipe symbols that are used here. This is pipe, thermally insulated pipe, jacketed pipe, cooled or heated pipe, flexible. So these are the symbols for different types of pipes that we're going to use in P&I diagram. Now there are two methods to illustrate when pipes cross on drawings but are not physically connected. So either you use a small hump to show one going over the other, a small hump you can see, or break one of the lines very near the other to show it going under it. So this is not a physical representation of actual pipes. In fact, they may not even cross in the actual system. It is merely a method to keep the lines separate when they must cross in the drawing. Now, communication or signal lines. So process control systems use various types of signals to communicate information between components, instruments and other control system computers, and each type of signal has its own line type to explicitly identify the type of signal that travels along with it. So you can see the pneumatic signal, then electronic or electric signal. So when pneumatic signal is flowing through this pipe, then you can see this symbol we are going to use in the PNID diagram. When electronic or electric signal is going through the pipe, then we are going to use this diagram. When hydraulic signal is going through the pipe, then we are going to use this diagram in the PNID. This is for guided electromagnetic, sonic or fiber optic signal, symbol for unguided electromagnetic, sonic or wireless signal, and this is for various data communication signal that are flowing through the pipe. So each type of signal has its own line type. As you can see, there is its own line type to explicitly identify the type of signal that travels along it. Now we'll talk about other common PNID symbols. So these are the symbols for vessels. You can see jacketed mixing vessel, half pipe mixing vessel, pressurized vessel, vertical, horizontal, then gas bottle bag. So these are the symbols of various types of vessels that we're going to use in PNI diagram. And these are the symbols for pumps, fans and compressors. So in this way the list goes on, and there are literally hundreds of symbols that represent all components that are used in process control systems. So heat exchangers, coolers, boilers, filters, etc. So now the instrumentation sensors. Now let's talk about the instrumentation. So instrumentation, that is consisting of sensors, transmitters and meters, etc. So this instrumentation refers to device that sense, measure, indicate, transmit and or record physical properties within a system. And for these types of components there is a slightly different approach. The components are represented by what is called bubble, and the bubble is a small circle, square or a hexagonal shape. So here you can see the various instrumentations, like if this is the case, then this represents a circle, represents that it is the primary choice or basic control system. A diamond here represents that it is the alternate choice or safety instrumented systems, etc. So all of these bubble types are further defined by horizontal lines or lack thereof, and these lines define whether the instrument is located and whether or not it is accessible to the operator. So as you can see, these are the various conditions. The horizontal lines or lack of lines will tell you whether the instrumentation is located, whether it is not, or it is accessible to the operator or not. So these are the various conditions. Now inside the shape, there are letters and numbers that are used to designate the property being measured. Typical functions are display so this property being measured and the function performed with that measurement. So typical functions are display, record, transmit, and control. So these are the few samples along with the chart of letters and what they represent for most common instrumentation components. So these instruments are identified by up to 5 letters. So you can see the first letter is the property being measured. The second letter is a modifier. Third letter indicates passive or readout function. Fourth letter is the active or output function. And fifth is the function modifier. So these instruments are identified by up to 5 letters as I've shown here, and the 5 letters means the things that I've written here in this slide. And this is followed by a loop number which is unique to that loop. You can see there is a loop number which is unique to that loop. For example, this FIC 045 means that it is the flow indicating controller. Yes, as you can see, flow indicating controller in the control loop 045. So this is also known as tag identifier of the field device, which is normally given to the location and function of the instrument. So this was all about PNID diagram and the software that are used for making PNID. That is, there are several different software packages that are available for creating PNIDs, and Lucidchart by Lucid Software Incorporation is one among them. So I'm ending this class here. This was all about PNID diagram. Thank you.